Good afternoon. Last lecture we have seen the first property of uniform continuous uniform distribution. In this lecture we have seen the next property of continuous uniform distribution. That is result second. If X follows uniform continuous distribution with parameter A and B, then X minus A divided B minus A is follows the uniform distribution with interval 0 to 1. Then we have prove this property. Prove that is f of x is the constant constant random variable of uniform continuous distribution. That is f of x equal to 1 minus 1 divided b minus a, and this class introduced a is less than x less than b. That is the value of x is between the interval a and b. Therefore, probability density function of y equal to PDF, that is probability density function of x, that is mod of j, that is j equal to dx divided by dA, that is b minus a. That is the probability density function of the y. And put this value, that is g of y equal to 1 by b minus a into b minus a, that is x plus equal to 0 to less than y less than equal to 1, and this get cancelled, that is g of y equal to 1 and plus equal to 0 to less than y than equal to 1. Therefore g of y, that is probability density function of uniform distribution, that is plus interval is 0 to 1, and hence probability density function of the uniform distribution follows the class interval 0 to 1. That is, we have prove this property. That is, here we have given the constant and constant function of the uniform distribution, that is f of x equal to 1 by b minus a, and this class interval is a less than equal to x less than equal to b. That is, value of x is between a and b. And then we have given the probability density function of the y, that is probability density function of x into mod of j, and j equal to dx divided dy equal to b minus a, and put this value put this function value in x into mod of j, that is g of y equal to 1 by b minus a into b minus a, that is here b minus a is cancelled, and then probability density function is equal to 1, and hence probability density function of the y is followed uniform distribution with interval 0 to 1. And here we have proved the property result of second. next property, if that is a result. Third, if x is continuous random variable with probability density function of x, f of x, and probability density function f of x, that is CDF, PDF and CDF, f of x, then y equal to f of x follows the uniform continuous distribution with class interval 0 to 1. And prove, let y equal to, we have considered the y equal to f of x and class interval is 0 to less than y less than equal to 1. That is, value of y is between the class interval 0 to 1. And dy dx, that is the probability density function of this y is equal to f of x and equal to j equal to d of y divided dx, that is dx divided dy equal to 1 divided f of x, and probability density function of y equal to probability density function of x into mod of j, and therefore j of y equal to the value of this function x is f of x into 1 by f of x, and class interval is 0 to less than equal to y less than 1. And here f of x is cancelled, and probability density function of the y equal to 1, and class interval is 0 to less than y less than equal to 1. Therefore, g of y equal to probability density function of uniform distribution follows uniform distribution with class interval 0 to 1, and y equal to f of x follows the uniform distribution with class interval 0 to 1. We prove the property of the uniform continuous distribution. That is, here we first we have to the function let y equal to f of x, and then we have give the differential, that integration of f of x, that is x divided dy equal to 1 by f of x, and that is we have put the probability density function of y equal to probability density function of x into mod of j, and probability density function of y equal to f of x into divided 1 by f of x, that is equal here f of x and f of x get cancelled, and probability density function of y equal to 1, and then we have prove the property of continuous uniform distribution.